Welcome back to Munro Live. So we are taking the opportunity today, since we have the Cadillac Escalade IQ, we have a physical sample in front of us. We've been able to do an exterior review and an interior review. But thanks to our partners with A2Mac1, they were able to provide us with the torn down components that are into the seats. And I wanted to kind of talk about some of these specific features. Now, this is a 3-row vehicle, but we only really have the components for the first row laid out here. Otherwise, this video would be very, very long. Now, as I said previously, second rows in 3-row vehicles, I think, are the most inefficient seats. So it would be interested to do a deep dive in those, but we're not going to do that today. So we're paying attention to the driver's seat. Now, the driver's seat, the primary seat, you are the owner. This is the comfort and this is the luxury that is being provided to you. So there are a few features in here that I wanted to show. One, you'll notice when we look at the physical seat that we have a fairly high seat back. So that high seat back foam, you'll notice that there are areas where they integrate features into the seat. Now, what these actually are, this is for the massaging function. The massaging function in the seat is done by these little pods that have an air pump to fill them up. Now, you would expect, or you would normally think when you think massaging, you think of vibration. This is actually moving and expanding for pressure points across your back. All of this being run off of a pump. Now, we see this type of features also with lumbar supports. Within the lumbar support, you have these bags that will go across the back of the seat on top of the suspension mat structure. These will inflate to push out for the lumbar. This is very, very traditional. This, not so much. So this is the mat that spans across the seat structure. This is what the foam sits up against. The lumbar, the little lumbar bags, would normally fit on this and push from behind the foam. Now, this is a integrated 2 big wires with an injection molded panel. They've done these in multiple different ways. Sometimes this will all be made of wires, like this sample here. This is the same type of structural support from another vehicle, but you'll notice this is just made with a bunch of bent wires. This would be more of a low cost, but I want you to think about this. All of these wires, there's a lot of flex, there's a lot of give. This type of a low-cost seat sometimes can actually, to some, be more comfortable because it has more flex. This is fairly rigid. It's going to prevent your movement. So sometimes the lesser expensive material actually provides you with more of a comfortable feel, more of a luxurious feel than what someone would anticipate as being the more high-end feature. So here's my actual seat back structural frame. Now, we've torn down many seats, but really in the past few years, we have not had too many seats from General Motors. So I don't know if this is unique to Cadillac, if this was a unique design for this vehicle, or if this is their corporate common seat structure that they will put into everything. Now, I'm looking at the welding. You'll see that these are basically a bunch of MIG welds. When we compare that to what we saw from Hyundai, which also makes the seat structures for Rivian, all of those welds were laser welds. The only time where they actually had MIG welding is when they would try and make that structure fit some feature that they had in Rivian that did not exist in Hyundai. Those features would be MIG welded on. So I don't know if this is their corporate common, this is their high volume for every vehicle and they're doing the MIG welding, or if this was a lower volume unique to this vehicle. I'm looking at the stamping. I mean, all of this looks fairly rough. I'm not entirely sure if this was from the teardown or if this is what's left over from the stamping process. But since it exists on both sides like that, I'm assuming that this is left over from stamping. I was very curious about these brackets. Now, the reason I'm curious about those brackets is because we don't really see cross supports like this on any of the other seats that we've torn down. Now, I was trying to understand, well, maybe there is some feature that is being supported by this. You'll see a round hole, then an oblong hole. That would be the primary locator, and then this would be the anti-rotation feature. More than likely, this is for fixturing, for when they're welding this together. I don't believe anything actually attaches to this. So why would they weld in this type of a cross support? Here is what I assume. I assume that this went into testing and they found out that they had some sort of an issue when they were pressing on the seat from one side to the other, and it was either collapsing or deforming. They threw these in as a Band-Aid to stop that. Now, this is my own assumption. I don't know if that's entirely true, but let me show you this other seat structure. Here's the seat structure from a very high volume vehicle. As you can see, all of the laser welds. This has been a seat structure that has been tuned to be very efficient, and it's used in many, many, many vehicles. But what I want to show you is this section here. You'll notice that if I look at this lower stamping, it's fairly straight, fairly thin, coming from side to side. But if I come to this, you'll see it increases up. There is this natural gusset that's being formed in here, creating a larger section on the side. What I assume is the shape of this stamping, creating that gusset, is giving them the strength that they need. But this narrower profile was not. Now, when this went into testing, you have a limited amount of time to respond from any type of a failed test before I have to go into production. So these structural supports, I would almost want to say is the kitchen sink method. Throw whatever we can at it to make it work. It's gonna pass. We have to pass the next round of testing. We can't tune it. I'm assuming that that is what this feature is. It does not need to be this big. It could have been smaller, but they did not want to take the chance of having another failure if they had a failure and make something more refined just to this tight area. They went all in to make sure that they're not going to have an issue. Now, again, this is my opinion. I don't know if that's actually what happened for the seat, but it makes sense to me. So moving over to the seat back panel, this is the rear of either the driver or the passenger front seat. Now, this panel has trim attachments integrated into it. So this panel would be in place. They can lock into these side features here. This panel has actual live stitching on the cover just down the center line. Now, if I flip this over, you'll see where they had to do all of the edge folds. Anywhere where you have what I would call this is an outside corner, you have too much material, so they would clip it out. But anywhere where you have an inside corner, there's not enough. They had to slice these in order to try and get it to stretch. This is always very difficult because as you slice them, it have the possibility of having these cuts being visible from the other side if you're not able to get it to stretch and lay down properly. Now, the other wrapped back panel that we really talked about was the Rivian. The Rivian back panel used a solvent-based spray adhesive. They only sprayed on this side. When they had to do the edge fold, we could actually see the brush marks. They hand brushed a solvent-based adhesive to do that fold. This one, this is a spray adhesive along the edge fold. This color and this texture, this is a water-based adhesive, not the solvent-based adhesive. Now, the difficulty with the water-based adhesive is if you are trying to glue to a TPO, TPO has poor green strength, meaning that this type of glue can peel up before you can even get it to secure and bond. Lots of times you end up having to do some sort of a process to flame treat. It's a big headache every time that I'm working with a customer that insists on a piece of plastic being TPO. They want it for the cost. They want it for the flexibility. If I want a piece of plastic that I'm going to glue to, I don't want to have to spend the money flame treating. I want an ABS part. And you'll see that is what we have here. This is an ABS panel, which means that the glue is going to stick to it. Now, we saw from the vehicle that we have for display that they have a video screen on this upper shoulder. Well, we don't have one in the headrest area here. How are they actually doing that? There's a couple of possibilities. They may have a completely different tool, a large back panel that has that type of a cutout. that they then have to wrap around inside of this edge to accommodate for that screen. However, in my opinion, and if I were developing this, what I would do, I would wrap this panel, and this would be the same panel for every vehicle. When I have a vehicle that has a screen, I would create a punch tool and I would punch out this section. You can kind of see this line. I'm almost assuming that that would be the line that they would punch. Now let's try and look at our static sample. This plastic bezel sits proud of the surface, and this is what is supporting the screen. In my opinion, you would punch and cut out this panel, and you'd have a small section that is then being covered up by this base. To me, that would make more sense. It prevents you from having to have multiple injection molding tools and other issues within your process. I'm only wrapping one back panel and cutting them as needed. So you see the width of this seat back. We would call these areas the shoulders of the seat back. This is quite wide, whereas our seat back panel gets very, very narrow, but this gets narrow below the foam height. Well, we don't want people in the second row seat being able to reach up, grab a big piece of foam and having it deform in your hand. We want some stiffness here. So how are they doing that? This is a plastic structure that is secured to the metal seat back frame. Our foam from the A surface mounts into that cavity, giving us the strength that we need to pull on. When we mount the seat back panel, you'll see it bites into this groove. So our cover is being stretched over, being locked in place. And then we have what we would call a bite to STO, locking this back panel in place. That's giving me the strength that I need, that grab point, but still being able to make it very, very smooth. It's not going to deform. It's going to be much cleaner execution over time. So this would be the cushion structure. Now, this structure would have some connectors, some legs on it. This is just the main part of the frame. I wanted to show you this to show how the seat pan would mount and integrate into that frame. This is what it's actually taking the load from you sitting on this seat. There may be some other suspension mat area down back here that would have more flex, but this would be locked. You'd have a pivot point here, and if you have an adjustable seat, this could glide up and down to provide a little bit more comfort. Now, one thing that impresses me, which I have seen on a couple of other General Motors vehicles, this pan is incredibly thin, incredibly lightweight. Now, because of that, if I hold it, you can see how much I can flex this pan. The question is that a problem? How much would this deflect during a crash situation? I'm not entirely sure. I don't know how their testing is done, but I have seen this type of a very thin metal on several vehicles. Now, this pan and this structure more than likely would be common for many GM vehicles, not just the Cadillac. But there's a feature of this seat that I want to point out that they had to address separately. You'll notice this wrapped cushion. Now you see how it goes all the way down to the bottom. Most of the time we would see the plastic come all the way around this front edge. All right, so we would see plastic seat cover stopping up, but this is a Cadillac, this is premium. They're taking that nice wrap material and running it all the way down. Well, how are they doing that? How are they securing this, and how are they holding this shape? Let's show you. So this piece of plastic would sit underneath the seat and provide that extra support going all the way down, allowing that cover to reach down. The foam would fit over top of that. And when I trim out my cover, I'm trimming all the way down to that plastic. Here's the problem. If I'm talking about this from a cost perspective, all right, normally we would have a plastic side panel. We don't have the plastic side panel, but we still have this plastic structure. So I'm still paying for the plastic either way. And normally, if we had that plastic side panel, our trim cover would stop much higher. But I am paying for extra foam and I am paying for extra synthetic leather material to cover that edge. So I've doubled the amount of material that I have to pay for because of that feature. This is a $150,000 vehicle. I expect that some of the money that I'm paying for the vehicle is providing me a look and providing me a comfort, providing me something that is different than a traditional plastic side panel. So to me, that type of an execution is worth it for the price of the vehicle. Now there is something that I do want to point out that I don't think is worth it, and it is the plastic side panel of the second row seat. Special mention, we're not really getting much into the second row seat, but this is something I feel that I have to call out. You'll notice that this has very sharp parting line edges. It looks very glossy, and then look at the grain. That texture is the same thing that you would expect to see in a very inexpensive vehicle. It almost makes you think that the word play school should be written on the side of it. So here's that piece from a torn down example. Now, that is from the second row. This is from the first row. These are actually different resins. If you look at the texture, they're actually different grains. And I don't understand that. Why would I have a different grain? The grains cost the same no matter what. This provides more of a matte surface finish, which in this vehicle I think would be more of a luxury type finish. When we look at the Rivian, all of the plastics in the Rivian R1T had a matte finish. They were also painted, but they also had this very, very light grain. This very thick, very, very heavy grain, I would say would be from a very inexpensive vehicle and does not make sense in this Cadillac. So for the first row seat, for the driver, we are looking at the seat back cover and the seat cushion cover. Now there's a couple things that I want to point out here. One, this is not leather. This is synthetic material. Personally, I prefer leather. Now some people make the argument that, oh, leather gets so hot. That is not true. Most people don't realize that what they think of leather in their car isn't really leather. I want you to think about this. If a welder is welding something and they want to protect themselves from heat, what do they use? Leather gloves. Leather is actually an insulator. When I used to make leather parts for vehicles and I had to do heat bonding, I had to turn up the heat and extend the cycle times of anything that I was making out of leather compared to anything that I was making out of synthetic material. Synthetic material sucks up heat and dissipates it quickly into your backside. Leather does not. Since it is a natural insulator, in my opinion and in my experience, true leather seats should not be hot. Also, it depends on how you finish the leather, but a true leather seat should not be glossy. When I look at this and I see this type of gloss, I automatically think artificial material. Now, if you're looking in an older vehicle and you have very, very glossy seats, that's because it's most likely body soil, body oils that have collected on that leather over time. If you do a deep cleaning, that leather would matte right out. So this type of a synthetic material, I'm not really sure what it is made out of. We say artificial leather, but in truth, artificial leather means everything. It could be PVC, which would be like the old Naga hide that you would see in vehicles from many, many years ago. Then we started going to PURs, and the PURs, PU materials, would be much more plush, more luxurious, higher cost. To my knowledge, which I'm not really sure if this is it, General Motors has been switching to a silicone-based material for their artificial leathers. Let's look at the material itself. Now, I have a bunch of blue material, then I have blue material with perforations. Do all of these come off the same roll? Well, let's look at the back. You'll notice that this material has different foam that's applied to it. Those foams are applied as a lamination process before the roll ever comes to the company that's going to be cutting these apart and sewing them into a seat cover, which means that this company for that material must have 3 different materials on hand that they have to use to cut all the parts, which means my utilization is hurt by that. This material with pink can only be cut from the material with that foam backing. If I have extra, I cannot cut these pieces out of this material. I am stuck with these pieces are only coming out of that roll, these pieces are only coming out of that roll, which may increase my scrap rate. So I have my foam. I have my attachment points for the seat cover into the foam. So I would take this cover, I would apply it, and I would lock my cover into all of these attachment points. So now I have this flap hanging off the side. In this flap, I am now sticking the airbag, and the posts are coming out of this edge. I'm pulling that around the foam, then I am applying this to the structure. So again, my airbag is in this little pouch. My cover is being stretched around. I have to then feed my airbag through the airbag bolt holes. I have to come in and access with the foam in place and bolt my airbag into place. When the airbag goes off, this material acts as a reinforcement material, which forces the deploy bag to go forward and tear out. Almost every one of my North American OEMs, this is the method that they use, but this is very, very labor intensive and cumbersome to install the bag. When I look at some of my Asian OEMs, they will actually secure the airbag into the structure before they put on the foam, before they put on the cover. They still have this material sewn into the cover, but they will have it open on the backside so that when the airbag goes off, it's still being driven forward, but I no longer have that cumbersome assembly. So from the A side of this cover, you'll see the perforations, and we've talked about this before. Look at it. These are not all the same hole. They're offset differently, they're of different sizes. They have areas where there are no holes, where they have these lines going top to bottom. So how are they doing this? I'm not just buying a roll of material with a bunch of holes on it. I am perforating all of these holes. Several years ago, we did a video at the Interior Expo, and we showed some of the machines that do this. They actually have different punch heads, and they can come through here and punch out that material. It's more of a CNC process. So I program where I want the punching to be, and the exact same machine can come in and do this stitching. That is what these lines are. Those are embroidered seams. And if you get in really close, you can really see all of the holes from that stitched material. That is just a line of embroidery from top to bottom. Understanding these materials and understanding these processes is what I do. When we are consulting with our customers, if it is an OEM, they are designing the outside of the seats, but they often don't design the components that are inside. They have a supplier that would normally be their tier 1 or their JIT supplier, and they're managing everything else. We can help our customers understand these are all of the steps that are going into your product. These are all the steps that are going into your seat. And we can help them rethink, are you putting the value where it needs to be for your customer? Do you have costs that we can cut out of the process and save you money, but yet still provide the luxury, the feel, the comfort that the customer may have? This is what I do, and this is what I enjoy doing. I almost tell people that my career has turned into graphical mathematics, because I'm trying to understand where all these costs are, what are the effects, how can we do these things better to save our customers, which would be the OEM's money, and then the final customer, the people that are purchasing these vehicles every day, how can we give them the product that they want, the comfort that they need, and coming in at a cost that is beneficial. So within Munro, that's what we do, that's what we like to do. So if you're interested in our videos and our reviews, please stick around, subscribe. But if you're interested in our process and how we bring value to our customers, you can also contact us and we can help you.